Welcome to our second lesson in Unit 3. This lesson is 7.2, the substitution method for solving systems of equations. Substitution method, we substitute the value for one variable in for the variable in the second equation. You'll see what that means here in a second. So here we can see we have a system of equations. We have the two equations. They are not in slope-intercept form, so it's going to be a little bit more difficult to graph those. You can do that, but I want you to work on trying all of the methods and being able to use all of the methods, okay? Efficiency counts here. So in substitution, the first thing we want to do is we want to rearrange an equation so that it has one of the variables by itself. In this problem, this top equation here is going to be the one I want to rearrange, and I'm going to rearrange that so it is in slope-intercept form, that y equals mx plus b form. So using my properties of equality, okay, I have my equation, and I'm going to add 2x to both sides. And so now that first equation becomes y equals 2x minus 1. Okay, notice that's in slope-intercept form. Now what I'm going to do here, notice how I put that in parentheses. That, when I say y, you're going to say instead 2x minus 1. So we're now going to take that second equation, that 4x plus 2y equals 12. Okay, and we are going to substitute anywhere I see y, okay, anywhere I see y, we're going to substitute in the 2x minus 1 in the new equation. So we've got 4x plus 2y. Oh, we're substituting in the 2x minus 1 equals 12. You see what I did there? I plugged in for y 2x minus 1, because in the first problem, when I said y, you say 2x minus 1. So it's like interchanging your first and last name. We just interchanged the 2x minus 1 for the y in the second problem. So now what we have here is a multi-step equation that we can combine like terms, distribute, and solve for the x. Okay, I'm going a little fast through here, hoping to not bore you too bad with the video. So we get 8x equals 14. Okay, did I make a mistake? It's not going to work out beautifully, is it? So I divide both sides by 8, and I get x equals 14/8, which is also 7/4. Okay, so now that I found what x equals, I can go back and plug in 7/4 into either equation and find the y value, okay? And so I'm just going to plug that into the first equation. So I have negative 2 times 7/4 plus y equals negative 1. And when I multiply, I get negative 14/4 plus y equals negative 1. And I'm going to add 14/4 to both sides. And I get y to equal, what am I getting here? Y to equal 5, that gives me 10/4, which is 5/2. Okay, so my solution to this system is going to be 7/4 and 5/2. You can leave things as improper fractions. Okay, we actually like to work with those a little bit better than mixed numbers. In this case, this is our solution to this system. And you can also plug those back into the second equation, and you will see that solution as well. Here we have another real-world situation. So a class with 26 students is going to the zoo. We have 5 chaperones that can drive the vans and the cars. Each van will hold 7 people cars hold 5. So how many vans and cars will we need? Oh, so first thing we have to do is write our equations. Before we write our equations, we should always define our unknown. So I'm going to let X be the number of cars and Y be the number of vans, okay? So in this case, we know we only have 5 chaperones, right? So that's all the vehicles we can drive. Nobody has a driver's license yet here, do they? So our first equation is going to be that X plus Y equals 5. That represents the number of vehicles we can drive. Now, how many people do we need to seat? We need to seat 31 people. We have 26 students and 5 chaperones, so we need a total of 31 seats. Okay, and we don't want to drive any vehicles with empty seats. So if we think about those seats, we get 5 seats per car, and we get 7 seats per van. So now we have this system of equations we can solve, okay? And I'm going to use substitution again. So my top equation, I'm going to rearrange that, and that is going to be y equals -1x plus 5. See what I did there? So this is the value I'm going to substitute in for y in the second equation. So in that second equation, I'm going to copy that, 5x plus 7y, and instead of saying y, I am going to place that -1x plus 5 equals 31, okay, equals 31 there, all right? So now I've got a multi-step equation using that distributive property, combining like terms, and solve. Let's do that math here. We get plus -7x plus 35 equals 31. And you're going to be like, what? This isn't going to work out. But it does. It does. Trust the math. So we have -2x plus 35 equals 31. Subtract 35 from both sides. And we are left with -2x equals -4. Divide both sides by -2. And we got that a little small there. X equals 2. So that means we need 2 cars. If we need 2 cars, 2 plus y equals 5. See how I substituted that 2 for x from down there in for our first equation? So then if we subtract 2 from both sides, we get y equals 3. So in this, we need 2, 3 is our solution. That's our point. More importantly, I would be looking for a sentence that tells me we are going to drive 2 cars and 3 vans to take all of the 26 students to the zoo. Nice job. Don't forget, if you have any questions, please place those in your post-video checks or send me an email.